Hello, Sanjay Kumar, am I audible? Please just check.
Yes, sir.
Okay, thank you. And slide is visible, question number one.
Yes, sir.
Okay, thank you. We'll start within 5 minutes. Let us wait for few students maybe join. Then
Okay,
after
sir.
we'll start. Or you can try to solve question number one.
Okay, sir.
Okay. Okay, let us start. So the first question is, let me take the pen. The first question, in the model test of spillway, the discharge and velocity of flow over a model were 2.5 meter cube per second and velocity 1.5 meter per second. Calculate velocity over prototype, which is 36 times the model size. So option A 3 meter per second, option B 6 meter per second, option C 9 meter per second, and option D 12 meter per second. So please everyone try to solve the question. Question number 1. So today we have the topic of dimensional analysis, the week number 5. The first question is the model and prototype concept. So please try to solve the question number 1. Everyone please, and write your answer in the chat box. Hello everyone, I am audible? Hello, I am audible, please.
Yes, sir, audible.
Okay, okay. So actually I forgot to unmute. So just please everyone try to solve the question number 1. The question 1 is, in the model test of a spillway, the discharge and velocity of flow over the model were 2.5 meter cube per second and velocity 1.5 meter per second. Calculate the velocity over prototype, which is 36 times the model size. Option A 3 meter per second, option B 6 meter per second, option C 9 meter per second, and option D 12 meter per second. So please everyone try to calculate question number 1 and write your answer in the chat box. Very important question. Anyone please write your answer in the chat box. Okay, let us discuss. So actually in the question, we have to test the model of spillway. So the discharge and velocity over the model, you can say here Q of model, M is for M represent the model. Qm is equal to 2.5 meter cube per second, and velocity of the flow over model, you can say the velocity of the model is 1.5 meter per second, right? Calculate the velocity over the prototype. You need to calculate v prototype, not vm. Vm is already given, so you need to calculate this one. And the scale is given, which is 30 times the model size. Means if I write here the model and the size of model in terms of length, and your prototype is equal to 1 by 36. Means what? Your size of prototype is 30 times of model. This is given in the question. This line, which is 36 times model size. Here you can say, for example, if your model is 1 meter, means prototype means actual size. Whatever the actual size, that is the prototype. The prototype, and model means what we conduct the experiment in laboratory, that is the model. Prototype means if model is 1 meter, it means the prototype will be 36 meter. So this is the meaning of this uh, which is 30 times the model size. Now come on the question. So we need to calculate Vp. You know all. So for calculation of this uh, the model test and all, that is, it is open channel. So we use here the Froude number similarity. Fr for model, similarly Fr for prototype, right? So this is, so here you can write the Vm divided by root G, or here you can say for rectangular Y, but we are interested for only the size parameter, length parameter, so I'll write here length, some length parameter, right? Similarly for prototype, Vm by root GLP. So here you can say Vm divided by Vp is equal to what? Gg will be cancelled out because for both prototype as well as for model, the Z value will be constant. So that's why from both side G will be cancelled out. Now what is remaining? Remaining part root Lm divided by root Lp means what? Vm divided by Vp is equal to what? Lm by Lp, Lm by Lp root. So this is the idea. Now Lm by Lp is given how much? 36, 1 by 36. So and Vm is given you 1.5. Vp you need to calculate, and here is given 1 by 36. So after calculation, Vp is equal to, here you can calculate 1 by 6. This will give you 1 by 6. So Vp is equal to 1.5 into 6. So means 9 meter per second. So this is your answer for Vp. So conclusion is that the conclusion for the question number 1, model, that is your model velocity was 1.5 meter per second and your prototype velocity was 9 meter per second. As you know, the prototype is the actual size. Why we working with the models? Why we work with the models? Why model? Because we need to understand, or you can use the prototype also for the study, but the cost of prototype will be very high. So that's why we make the model size. For modeling, that is for, let us suppose this is your structure, actual structure. In model, the structure will be this size. The size of the structure will be reduced. But for modeling, we need to make the similarity 3. We need to maintain 3 similarities. One is geometric, another is, we'll see later, geometric, another is kinematic, and third one is the dynamic. So these 3 similarity will be important for your prototype to model studies. And why we need? Because of the understand the characteristics, what is happening near the spillway and all. Okay, so based on that, based on the study and based on the result, we design the spillway and all. We focus the where should be the velocity more and where the velocity will be less, and where erosion prone area in the downstream of the spillway. So that all things we learn with the model, then implement on the when we go for the prototype construction. Now we'll move on the next question. Next question is, okay, here is the next question, question number 2. So dimensional analysis is used to, test the dimensional homogeneity of any equation of fluid motion, derive rational formula for a flow phenomena, derive equation expressed in term of non-dimensional parameter, all of the above. So please everyone try to give your answer in the chat box for question number 2. So hope you all got the question number 1. What was the concept behind the question number 1? And if everyone got, please you can write in the chat box yes, the solution of question number 1. and you also write the answer of question number 2. Which option will be correct? For question number 2, please everyone write your answer in the chat box. Dimensional analysis is used to test the dimensional homogeneity of any equation of fluid motion, derive rational formulas, rational formula for a flow phenomena. Third, derive equation expressed in terms of non-dimensional parameters. And option D, all of the above. So this is a very basic question. Please, if you have any doubt, you can ask. Otherwise, you try to give the answer of question number 2. Question number 2 is very basic question from your dimensional analysis. So I am expecting the, please everyone try to or write your answer in the chat box. Okay. So the answer of, okay, the Manikumari is telling option A, the test the dimensional homogeneity of any equation. Okay. So let us discuss. Actually, the your dimensional analysis we use for homogeneity test also, for derive the rational formulas also, and derive the equation expressed in terms of non-dimensional parameter also. That is, you know about the Buckingham pi theorem and the Rayleigh's theorem, you all know. So all these three things we do with using the dimensional analysis. So all option will be correct. Now next question. Next question is question number 3. Okay. In which of the following method of dimensional analysis a function relationship of some variable is expressed in the form of exponential equation which must be dimensionally homogeneous? Whether it is Buckingham pi theorem, Buckingham pi method, and Rayleigh's method, Riesgum method, and your matrix tensor method. So you have the four options: Buckingham, Rayleigh, Brisbane, and the matrix tensor. Which option will be correct for question number 3? Everyone please think. Okay, the Mani Kumari is telling option D, matrix tensor. Okay. Other student please also try to write your answer, then we'll discuss. Okay, D was for question number 2. Okay, okay. For question number 3, please everyone write your answer. Here is the main focus point is in question number 3 that we have to put the variables in form of exponential equation. Okay, you are telling the option A, Buckingham Pi theorem. Manikumar is telling option A. Other student, please also try to write your answer for question number 3. Let us discuss. For question number 3, actually here the question is asking about the methods of dimensional analysis. A function relationship of some variable is expressed in the form of exponential equation. So in form of exponential expression, we actually express in the Rayleigh's method, not in the Buckingham, not in the Brisman, and not in the matrix tensor. So your option will be B correct for this question number 3. And also I have the PPT regarding the Rayleigh's method and your Buckingham Pi theorem. So I'll show you. So let us move on the next question. Here you can say the detailed solution. The Rayleigh's method show a functional relationship of some variable is expressed in the form of an exponential equation which must be dimensionally homogeneous. Now the next question. Okay. Next question is in dimensional analysis of Buckingham Pi theorem, which widely use and express the resulting equation in terms of. In dimensional analysis of Buckingham's pi theorem is widely used and express the resulting equation in terms of the repeating variable, in terms of the geometric, kinematic and dynamic variable, in terms of n minus m dimensionless parameter, and in terms of n dimensionless parameter. So please everyone read very carefully the question, what is asking, then after you try to write your answer in the chat box. Everyone please try to write. Try to think, first think and then you try to write your answer. Okay, Manikumari is telling option A in repeating variable. Okay, in terms of the repeating variable. Actually, what is here N and what is M, that should also be included in the question. So question is incomplete, not completed. Okay, I have the PPT, so I'll show you once the question will be finished. So I'll show you about the Buckingham Pi theorem and Rayleigh's method both, as well as the concept behind your dimensional analysis. So here answer is, now we'll discuss. So here answer is your m minus n dimensionless parameter in Buckingham Pi theorem. Please everyone remember. Now question number 5. Question 5 is, the distorted models are required to be prepared for which of the following? A river, a dam across very wide river, harbors, all of the above. Distorted model. What is distorted model and what is non-distorted? So these things, okay. Before discussing the question, I want to go with the PPT. So I think you will get the more clarity about that. So let me discuss. So I'll just, I'm going to show you. Please wait. Let me share entire screen. PPT is visual. Please everyone just comment. Not just you tell, because I am unable to see your comment. So PPT is visual. Week number 5 hydraulic engineering. Please anyone say yes. Okay, now visible, no? Okay, okay. Okay. So the slide is visible. Please everyone just tell me. This Apple one is visible. This slide. Okay, okay. Because I am unable to see your comment when I present the PPT. So if anyone tell yes or no, then I can only understand. Okay. So if not visible or not you able to see or not you able to hear me, so you can just tell whether you are able to uh, able to see or not the PPT, and whether you are able to listen my voice or not. So now we'll move on the question number, that is the concept. So dimensional homogeneity means what? Dimensional homogeneity is, so you have to maintain these things. That is, if you are going to add, that is your apple here also you need to put the apple, so that you can add. So if you are putting here orange, you cannot add. So that's why for adding, dimensional homogeneity means if you are, let us suppose here velocity is given 2 meter per second and length is given 2 meter. So you cannot add these two things. But if L1 is given 3 meter and L2 is given 2 meter, you can add 2 plus 3 meter is 5 meter. So this thing you can add. So this is the meaning of dimensional homogeneity. And here we have the primary dimensions: mass, length and time, and your temperature, electric current and amount of light, as well as amount of matter. So what is actually dimension? Dimension is a measure of physical quantity without numerical values. While unit is used assigning a number of dimension. For example, length is dimension. The length is what is? Length is the dimension, right? But centimeter is the unit. So hope you got it. What is the length? Length is dimension, but centimeter is unit. So length, let us suppose here the length is 3.2, but whether it is meter or centimeter, so you need to give the unit, so it is centimeter. So basic, so dimensional analysis and similarity. What is dimensional analysis and similarity actually? So similarity means, yes, here you can see the figure, this figure, and the similar figure you can see here, three, these things. So these are the similar, but the size is small. The size is small. So for similarity, you have to do three things. First one is the you need to maintain your geometric similarity, and then the kinematic similarity, and then after your uh, dynamic similarity. So you have to three similarity maintain. Okay, geometric, geometric similarity, kinematic similarity, as well as your dynamic similarity. Here you can see you need to maintain. In general, here you can see the concept. In general flow field, complete similarity between a model and prototype is achieved only when there is a geometric, kinematic and dynamic similarity. We have, if you have the three, then you can say the your thing is uh, complete similarity. That is, you have model your prototype completely similar. If you not have, like suppose if you have maintained only the dynamic that is your geometric similarity, not kinematic and dynamic, then your model is not complete similar. So that type of model we known as the distorted model. That type of model we known as distorted model, or you can say the distorted model is distorted. If you are assuming the geometric similarity, let us suppose if you are making a channel like that. If you are making the channel, so channel have depth as well as length as well as width. So in width, let us suppose in the length you have maintained the 1 is to 40 or 1 is to 400. In width also you have maintained 1 is to 400 scale. In depth also you have to maintain 1 is to 400. That if you have maintained these three things, then your model is that is your non-distorted. If you have not maintained the 1 is to 400 in terms of, in the case of depth, then your model is distorted. Remember, because let us suppose you have made, in case of length, that is the length of the river, you have model like 1 is to 400. Width you have measured 1 is to 400, but depth you have measured 1 is to 40. So your model is distorted. So why actually in case of open channel or river, so we assume depth similarity like small, very small compared to the length and width. Why? Because of if you because in the river the depth is very less compared to the width. The depth of the flow is very less compared to the width as well as length. So when you will consider 1 is to 400 in case of depth, your flow will be very less. Flow will be very less, so you cannot even measure anything. So that's why in case of river, dam, everything, whatever the open channel, we assume the distorted model because uh, we cannot scale down length, width, and depth with same scale ratio. So remember, please. So now what is your Buckingham Pi theorem? So it is very easy. So these are the concept behind your Buckingham Pi theorem. So actually we have the some dependent as well as some independent parameters. Let us suppose you are going to model something, some physics. You are going to model something, some physics. So in that phenomena you have some dependent parameter and some independent parameter. Means what? If you are going to measure, let us suppose here one example is given, very uh, good example. So here you are going to model one, your, let us suppose, car. You are going to study the aerodynamic of the car. So how you will maintain the geometric similarity? So let us suppose your variable, maybe for you are going to measure any, understand any physical phenomena, your variable will be dependent as well as independent. Remember, dependent as well as your independent. So number of phi, here you can see the parameter phi1 in general, a function of several pi's, which we call the independent pi's. The function relationship like that, phi1 is equal to function of phi2, phi3 as well as phi k, means number of phi's. So here you have to understand. So that is your, let us suppose you have the many variables, so you have to write your Buckingham Pi theorem like that first of all. So I have one example so you can understand very clearly. So here you can see one example of your dimensional analysis, prototype car and model car. So here actually what we, the question is, consider for example a design of new sport car, the aerodynamic of which is to be tested in wind tunnel. So we are going to test the aerodynamic. Aerodynamic means what kind of and how air flow around the car, that is the test known as the aerodynamic flow. That is, we are going to test the wind tunnel. To save money, it is desirable to test a small geometrically scaled model of the car. So for save the money, we have make a small car with the geometrically similar than the full scale car. Here you can see. In case of aerodynamic drag on an automobile, it turns out if the flow is approximately as incompressible and there are only two pi's in the problem. One is your Froude number, one is your drag force, another is your Reynolds number. So we have the two here dependent and independent variables. So one is your drag force, another is your Reynolds number. So the procedure used to generate these pi's is discussed in the, we have the section, another section. And in equation 730, here you can say 713, Ft is the magnitude of aerodynamic drag and rho is the density and V is the car speed. L is the length and mu is the viscosity. Pi 1 is a Pi1 is a non-standard form of the drag coefficient. Pi1 is the non-standard form of the drag coefficient and Pi2 is the Reynolds number, what I have tell you. And you will find the many problem in fluid mechanics involve Reynolds number. Yes, this is obvious. So now in the problem of hand here, only the independent pi, that is equation 712, ensure that the independent pi match then the independent. So okay, we'll not discuss this one. So whatever the idea is, so for modeling we use your model is small compared to the prototype because of the to save the money as well as time also. So here is your method, that is the Buckingham Pi theorem method. So very important, the steps is given here. List the parameter in the problem and count their number of n. What were in the previous question, what we have seen, m minus or n minus m. So m n we have seen. So what is m and what is n? Here you can see the step one, list the parameter in the problem and count their total number. So the parameters whatever in the problem parameters is, or you can say the variables, that is known as n, that is the total parameter is n. Total parameter is n. Now list the primary dimension of each of the n parameter. Let us suppose you have the velocity and you have the density and you have your dynamic viscosity, and you have also, that is you can say the temperature also, you can say. So like that. So now here is the parameter n. You need to count the primary dimension. Whatever I have shown you the primary dimension here, this is the primary dimension. Is there any dimension in your parameters that is a primary dimension? That thing you will note. Okay. Then step 3, set the reduction j as the number of primary dimension. So number of primary dimension, let us suppose here you have meter, here also meter per kg per meter cube, meter per second, and here your Newton second per meter square, and here is your theta. So you have the primary dimension, what meter you have time also, you have theta also. So like that you will consider, right? And you have your length, time, okay, and kg also you have. So these are the primary dimensions. So and set the reduction as the number of primary dimension. So here is the reduction means whatever the m was given the previously. So here is in this book written the j. So number of reduction is whatever the primary dimension is here. Choosing the repeating parameters, now you will choose the repeating parameters. And how you will choose j repeating parameters, and whatever the j means whatever the your primary dimension will you will get, that will you use as a repeating parameters. Then construct k pi's and manipulate as necessary, and write the final function relationship and check the algebra. So these are the procedure. Here is the very well written, so I'll share with the ppt also with you. So you please you go one by one, you can very easily got the concept behind your pi theorem, that is the Buckingham pi theorem. So now we'll move on the question number on the questions. So that's all the basic fundamentals. So okay, so here question number 5 you can see. So please everyone try to write the answer of question number 5. The distorted model are required to be prepared for which of the following: river, dam across very wide river, harbor, all of the above. For question number 5, please everyone try to give the answer. So in question number 5, about the distorted model, are required to prepare for which of the following? Please everyone try to give your answer. After this question, I'll take 5 minute break. So you will also take. Okay. Manikumari is telling option D. Other student, please also try to give your answer. I have tell all the concept, that is the basic concept of your distorted model and the non-distorted model, and also about the Buckingham pi theorem also I have tell you. Anyway, I'll share the PPT. You please everyone go through the PPT so you will get the concept. Okay. Gopal is also telling D option. So now we'll discuss. Actually, we use the distorted model for open channel, as I have told you, the river, dam across and harbor, as well as your all of the above. So why? Because I have told you, because the length of the river is very high and width also very high compared to depth. Compared to depth is very. Let us suppose 1 to 2 meter of the depth of the river, but width may be your 1,000 meter and length may be so many. If you want to study a river length, that is your 1 kilometer, or you want to study the 5 kilometers, so 5,000 length you have to study. 5,000 length. River length is very high, but you want to study only 5 kilometers, so that's why the length is 5 kilometer, width is 100, width is 1,000 meter, as well as, or you can say the 1 kilometer, or your depth may be 1 to 2 or maybe 5 meter. So when you will scale down, let us suppose here if I scaling, scale 1 is to, I am going to take 1 is to 500 or 1 is to 250. I am going to take 1 is to 250 scale. Means if your the river length, the length of river is 250, means length of channel in the lab, length of channel or length of model will be 1 meter. So length of model will be here, length of model will be how much? If 5,000 is how much? Please everyone tell, because if you will tell then you can very easily understand. So length of the model how much should be? Everyone please, anyone please write. We are using the scale here 1 is to 250, and 1 is to 250 means if the river length is 250, you have to make, you have to construct a channel in lab 1 meter only. So if you have the 5,000 length, then how much? Okay. So here I just use, so 250 means what? 1 meter. So 5,000 means what? Or you can say here 1 means what? 1 by 250, 1 meter. So similarly 5,000 means what? 1 by 250 into 5,000. So how much? 0 0 cancel out and 25 to the 50. So that is 20 meter. Length will be 20 meter. Similarly, your width of the model is how much? So 1 is to 250 into 1000. 25. 25 for the 100. So here is 4 meter. But in case of depth, let us suppose depth is 2 meter. Depth is 2 meter. So depth is how much? 1 by 250 into 2. So let us suppose in meter it may be the fraction. In case of centimeter, how much? Let us suppose here 2. So approx 1 centimeter or less than 1 centimeter. So approx 0.8 centimeter. So 0.8 centimeter, whether it is possible to flow, whether it is possible to flow in the lab. Everyone please tell whether it is possible to flow in the lab. 0.8 centimeter not possible. If let us suppose somehow if possible to flow in the lab 0.8 centimeter, but you cannot measure anything. You cannot measure anything in the lab with the 0.8 centimeter flow. So that's why we use in case of open channel flow distorted model. In case of that is at the place of non-distorted. So the explanation, let us see the explanation here. Let us see. The explanation is very well written. So hydraulic modeling of river, harbor, estuaries, etc., which have longitudinal slope and large aerial spread, pose any practical problem if strict the similitude is attempted. To overcome most of these problems, they are usually modeled by using the distorted scale. Distorted model are those which are not perfectly geometrically similar. Distorted model are those which are not perfectly geometrically similar. Remember please, distorted model are those which are not perfectly geometrical similar to the prototype. Different scale ratio is used in different direction, particularly in case of shallow river where the depth is small compared to width. Without distortion, the depth of flow in the model will be so small, whatever we have seen 0.8 centimeter, so small that measurement may not be accurate and surface tension effect will be prominent, and which will not present in prototype. Hence, it is necessary to distort the model. It is necessary to distort the model in vertical direction. In the design of model, hydraulic similitude of hydraulic similitude is of the prime importance and not that the geometrically similars. So therefore, by distortion of the model scale, even though the model is not look like the prototype, but it gives satisfactory result. So hope you all got it, the point behind the distorted model. So this is very important. So now we'll move on the next question. Next question is, yeah, next question is very easy. So question number 6. So I'll take break, then after I'll discuss about question number 6. Okay, let us discuss question number 6. So question number 6, in a tidal model, the horizontal scale ratio is 1 is to 500 and the vertical scale is 1 is to 50. What model what model period would correspond to a prototype period of 12 hours? Okay, so let me discuss. So actually, your here we are discussing about the period of time. That is the prototype period is 12. So what is the model period? So actually, the your time ratio is here. You can see your time ratio is that is LR by root HR means what? TM by TP is equal to LM by LP divided by root under your YP, that is your vertical ratio, that is the so HP HM divided by HP means what? H means height here, the HM model divided by HP. So this is in the question is given your LM by LP is given 1 by 500 and this is given 1 by 50 and your TM, when you will calculate this you will get this one 0 1 4 1 4. So your TM is equal to 0.01414 into TP. So TP is given how much? 1414 into 12. After calculation you will get 12 hour is given. So you need to convert in second because answer in second. So here is 60 minute, 12 hour is yes 60 minute into 60 second. So after calculation you will get 610 second. So you have to remember these things. Your time period is the time ratio is the ratio of your horizontal scale divided by your root over your vertical scale. Okay. So now we'll move on the next question. Question number 7. Very easy. The dimensional formula for relative density M1 L3 M1 L1 minus T1 M1 L1 minus T2 M naught or L naught or 0 T naught. So please write your answer in the chat box for question number 7. Everyone please. Okay, please everyone tell. Then I'll tell you the concept for your time ratio. I'll show you the concept how the time ratio is equal to your TR divided by root HR after this question. So this is only fraud number similarity, but I'll show you. The dimensional formula for relative density. So just for hint of this question number 7, so the relative density is the ratio of your density of anything divided by density of a standard fluid or a standard fluid you can say in case of the fluid mechanics. So it is the ratio of density by density. Now please you guess the dimensional analysis of relative density. Everyone please. So now discuss. So your relative density is nothing. That is the density of whatever you want to find out. Density of, let us suppose you have find out the honey. So density of honey divided by density of water. So this is the relative density. So after putting the your dimension of this, so what will the cancel out? So that's why there is no dimension. So a non-dimensional parameter, relative density is non-dimensional. So that's why your D will be correct. Option D. Okay, but now here I want to show something. The concept of your TR, that is the time ratio. So here also we need to do this fraud number similarity. FR model is equal to FR prototype. So here model means what? Velocity of model divided by your G or one length parameter you can say LM, not LM here. Here because here we need to also consider your what? That is the your uh, depth parameter. So that's why here we need to put, because fraud number is what? Fraud number is velocity divided by root GD, and your D is equal to here area by top width. So if I consider the rectangular, so width, top width and width will be cancelled out, only depth will be remain here. So here we write the your height parameter, that is HM. Remember, and here also your M, that is your prototype. Similarly G, H prototype. Now what is velocity? Velocity is meter per second, means one length parameter is here. So LM length parameter divided by, and one time parameters also TM, divided by G will be cancel out both side. So HM is equal to LM LP divided by TP divided HP. So now we need to calculate at Tm by Tp. So let us write in manner. So Tm by Lm by Tm root Hm is equal to Lp divided by Tp root Hp. Okay. So now Tm by Tp. So this side will go Tm. So Tm by Tp, and this your Hp will be Hp by Hm, and your Lm by Lp. So now you can write this one. Lm by Lp, we write Lr, and Hm by Hp. We have always remember this. The model will be in the nominator and prototype in the denominator. So Hm by Hp is equal to Hr. So here HP in the nominator, here HR will be when your model will be in nominator, but here your prototype in nominator. So that's why that is HP by HM is equal to what? 1 by HR. Just opposite 1 by HR. So here 1 by HR you can write. LM by LP is LR, and this is 1 by HR. So TM by TP. So Tm by Tp is equal to Tr, you can say Tr, and this is Lr by, or in the root, the Hp and Hm in the root, so that's why you will put here root. So your Tr is, now you can see here, Tr is Lr into 1 by root Hr. So you can write very easily Lr divided by root Hr. So this is a formula, time ratio. Like that we will calculate. Okay, hope you got it. Now we'll move on the next question. Question number 8. So here you can see the explanation, detailed solution. Relative density is the ratio of density, that is mass and unit volume, that is density kg per meter cube, mass and unit volume of a substance to the density of given reference material. Let us suppose you want to find out any density, find out of the density of your mercury with the reference of honey, with the reference mercury, that is a relative density of mercury with the reference of honey. So these things will represent your, the meaning of line is this. And the specific gravity usually mean the relative density with respect to water. The relative density means you can change here the things, that is honey, or you can change, you want to find out the density of, the relative density of, suppose that kerosene with respect to, let us suppose with respect to honey or with respect to your mercury. So like that you can change the standard fluid from the denominator part, but in specific gravity generally not, this is the standard, but generally we put the density of water, remember. So it is dimensionless quantity or no unit. Okay, we'll move on the next question. Next question is this, question number 8. A geometrically similar spillway model is constructed to a scale 1:12, corresponding to a discharge 998 cubic, that is meter cube per second in the prototype. The discharge in the model in cubic will be, so 1 cubic, 2 cubic, 16 or 64. Everyone please try to calculate. Everyone try to calculate the answer of this question, question number 8. Everyone, please try to calculate. These are the very important questions. So please, everyone, try. You have 5 minutes for this question. Try to first find out the relation, that is a scale ratio relation with using the fraud number similarity, and then move ahead. Okay, Ranjit is telling B option, that is 2. Okay, 2 cubic. Other student, please also try to calculate. Okay, let me discuss. Okay, here also you need to maintain these things only. The that is your fruit numbers. FR model as well as F for your prototype. You should maintain. Here we have to find out your discharge things. So what is discharge actually? So you know one thing, you can write like that also. VM into area M. means what? Qm is equal to, Vm and Qp is equal to Vp into Ap. Just divide these two equations. Qm by Qp is equal to Vm by Vp, or you can for this Lm by, that is your area means what? L square. So you can write Lm by Lp square, and Vm by Vp you know already, that is Lr, root Lr. Vm by Vp is root Lr, and this Lm by Lp. So root Lr means what? Power half, and this Lm by Lp means Lr, that is 2. So when we will add, that is your 1 by 2 plus 2. So now you can write very easily. Lr is equal to 5 by 2. So your QR is equal to Lr power 5 by 2. That is 2.5. So now you can very easily calculate. Scale ratio is how much? 1 by 12, 2.5. So QR, that is Qm by Qp is equal to 1 by 12 to the power 2.5. So here Qm is equal to 112 2.5 divided by, that is into Qp. So Qp is how much? 998. So after calculation you will get, let me just calculate, or I don't have calculator. So let us see. Okay, 2 will be correct. That is your, in spillway model the fruit law is applicable. So hope you got it. Okay, so another way you can also think, FRM FRP. So you know one thing, what? Velocity m divided by GLM, velocity p divided by G. Why I am writing here not y or h? Because of here not given the spillway geometrically similar. Geometrically similar means your width and length, everything, or depth, everything is same. The scale of the everything, that is length, width, and your depth scale is 1 is to 12. That's why I have written only one. Okay, LM, and here also GLP. But here we need to find out the discharge. So I'll multiply here AM, here also AM. No effect. AM, here also AM. AP means AP, and here also AP. Now you can write QM divided by AM, GG will be cancelled out, root LM. Here also VP AP is QP divided by LP into AP. AP means what, or LM means what? QM LM square LM 1 by 2 equal to QP LP P2 and LP square. So now you can write Qm by Qp is equal to what? Lm 5 by 2 and Lp 5 by 2. Here when we will add these two things. Now Lm by Lp is Lr 5 by 2 and Qm by Qp is Qr. So hope you got it. You can go in two way for your find out the scale ratio in terms of discharge. Now we'll move on the next question. Question number 9. Very important. Here also you have 5 minutes for question number 9. A river model is made to a length scale ratio 1 is to 50 and the depth scale ratio 1 is to 16. A peak discharge of 25,600 meter cube per second in river will be simulated in the model with discharge of 4 cubic, 6 cubic, 8 cubic, 10 cubic. Everyone please try to write your answer in the chat box for question number 9. Here the your depth as well as your length ratio is different. So remember, you please go with the second way what I have told you in the just previous question number 8. In that way you try to solve the question number 9. Everyone please, you have 5 minutes or you can take 6-7 minutes also, because this is a when you will attempt, then I think the question will not take more than 5 minutes. Everyone, please try. You have another 2 minutes. After that, I'll discuss. Question number 9. Okay, let us discuss. Question number 9. So here is again, you have the peak discharge, this value, and you have the two ratios. So here you will go with this only, FR model, FR prototype. So Vm divided by G, and here is your height ratio, that is depth ratio. I'll write dm. Again, your Vp divided by G dp. So velocity also you write in terms of, that is the meter or second. Here time ratio is not given, so that's why. But here one thing more, you have discharge value, so you need to multiply with am. Here also am, here am, ap into ap, right? So area is what? Area of cross section actually. Area of cross section means depth as well as your width. Width means that is L. Length ratio, that is horizontal length ratio L, you can say. So here you can write QM divided by DM LM root DM equal to QP divided by DM DP LM LP root dp. Now qm by qp is what? dm by dp into lm by lp into root dm by dp, root dp. So this is 1, that is the power is 1. Here power also 1. and here is power 1 by 2. So 1 and 1 by 2 is 1 by 2 means 0.5. 1 and 0.5. So Lm by Lp into dm by dp to the power 1.5, because this is 0.5, the power is here 0.5 and here 1, so 1.5. Now you can write qr, that is qm by qp. I am going to write with r, that is m by prototype. M by prototype is r. So here also lr, and again here also your dr power 1.5. Now you can put LR is 150, DR is 1 by 16 power 1.5, and QR is QM by QP. So here you have the QP value, you need to calculate QM. So 1, your QP will be, you can write here, that is 1 by 50 into 1 by 16 to the power 1.5 into QB is 25600. So you will get QM is equal to whatever you will get here. Let us go with the answer, 8 cubic. So remember please, like that you will solve. So hope everyone got it, the concept behind your this. Here also you can say the vertical, and this is vertical, 1 power 1 and this power is 0.5, so 1.5. The similar thing is written here. Okay, we'll move on the next question. Next question is question number 10. The Mach number is defined as a square root of the ratio of inertia force to pressure, inertia force to surface tension, inertia force to elastic force, inertia force to viscous force. We are discussing about here is about the Mach number. So everyone please write, at least everyone please write the answer of this question number 10. Mach number. Everyone please write whatever you know, you can write, whether A, B, C, D. The inertia force by viscous force is what? The Mach number is defined as a square root of the ratio of what? The inertia force to viscous force, the square root of inertia force to viscous force gives us Reynolds number. And inertia force, square root of inertia force to viscous force gives us your inertia force to gravity force, gives us Froude number. So here the gravity force is not here. But in option D, your Reynolds number you can define. But another three, Euler number, Weber number, as well as your Mach number, you have to understand everything. Okay, option C, someone telling option C. Anurag is telling. Okay. So we'll move. Yes, option C will be correct. Mach number. Just ratio is square root of, that is your Mach number is square root of inertia force divided by your, that is square root of what? That is elastic force. Inertia force, elastic force. You can write like that. Now, question number 11. A model 1 is to 20 of a spillway discharge. Find the corresponding discharge in the prototype. Similar formula. The discharge you know already. That is the Qm by Qp is what? Lr to the power Lm, or you can, I want to write in full, Lm by Lp is 2.5. So here you can write The model discharge is 8. So what is the prototype discharge? So prototype discharge is QM, that is 8 divided by LM by LP is given 1 by 20 to the power how much? 2.5. So you will get here QP is, maybe let me just show you. So like that, just please everyone tell what is the answer of this question. You have to calculate. For question number 11, please everyone, the answer of question number 11. I think we have solved today lots of problem based on your discharge, that is the discharge ratio, Lm by Lp, as well as your velocity ratio, time ratio. So these are very okay. Simal is telling option C. The okay, that is 16312 is coming. Okay. Oh, Anurag is telling option A. Please, both you can recheck your answer, recheck your calculation. Recheck your calculation and anyone correct, whether A or C. Okay. Simal was telling for the previous question. Okay, C. But for this question, Anurag is telling okay. Oh, I was confused. Okay. So for question number 11, Anurag is telling option A. Other participants also want to write? Okay, no one. So yes, let me just see. Yes, option A is correct. Now we'll move on the question number 12, which is your from Buckingham Pi theorem. Okay. To apply the Buckingham Pi theorem, M repeating variables are selected from among us of n variables influencing the phenomena. The repeating variable are selected such that they belong to kinetic dynamic category of variable, must always contain the dependent variable, in combination contain each of the m fundamental dimension involved in the problems. None of the above. Which option will be correct? For question number 12. This is the last question for today. And please, everyone write. For question number 12. Okay, let me just show you the answer. For question number 12, actually option C will be correct. Your repeating variable should be, that is combination contain each m fundamental dimension involved in the problems. So always remember please, the repeating variable in Buckingham Pi theorem is selected in combination contain each of the m fundamental dimension involved in the problem. So that's all for today. We'll meet again in the next session. So thank you all. Bye bye. So now please you can leave the class. Hope you all enjoy that for the today session. Okay, please everyone leave.